Okay, now so I'm just gonna show you how to fit your existing data with the logistic curve. Um, so this is the lecture about the logistic curve that I want to talk about. Actually, for the logistic curve, sometimes we just call it a Pearl curve. So this curve is actually having this function. So the value is equal to L divided by 1 plus A e to the minus BT. So L, A, and B are just model parameters that we have to estimate. So in the Excel sheet, we want to estimate the value of L, A, and B. So let's just move into the Excel sheet. So I listed L, A, and B in the cells F2, G2, and H2. So we just randomly pick a number for L, A, and B. So I'm just gonna say, 100, 15, and maybe like 5. So these are just randomly picked number that we selected. Note though that these cells, I specify the names for the cell just to make it more make more tips for you. You can also name each cell. So in order to name the cell, you can do like define name, and you put the name like L, and you just put the value that you want to refer to. So L is this value, and then you click OK. But since the name is already existed, already created, so this is not going to be able to do it. But if I show you in Name Manager, I have already specified the name for the L, the A, for the B here. You don't have to do it. You can just refer to the cell number. That's fine. But this is just another tips that you can do. Now, after you specify the L, the A, and the B, we can put the function for the logistic function in column F. So this is basically L divided by, note that, once you have named the cell, this is going to show the name of the cell rather than showing F2. So, it's up to you if you want to, if you are using it a lot, then it might be okay to name the cells to make it more sense about what you're doing. So this is basically L divided by, just a second. So this is actually L divided by 1 plus A times exponential of minus B times C5. So C5 is year number 1. So this is just the predictive value using the logistic curve. And now you have all the predictive value here. Once you have all the predictive value or the forecasting value for using the logistic curve, we want to find the square error, not the sum yet. So the square error is just basically, this predictive value minus the actual value, and you can see that this is going to be a lot, and this is going to go square. So you find the square error for all the 11 years that you want, and now you want to find the sum of square error. So this is basically the sum of all square error listed in cell C3. Okay, so once you have this set up, then you can go to solver. I already did it, so everything is set up here. You can see that we want to minimize C3, so this is C3 to minimize. You want to change the cell F2, G2, and H2, so we say F2 to H2. These are going to be the ones that we want to have the optimal solution. We also need to specify the range of L, A, and B. So first thing first, that we want to say that L, A, and B should be greater than or equal to 0. Well, in order to add, these constraints, let me just delete it. I'll do it again. The way that you can do it is that, you can click add, and then you select the range, and then you select greater than or equal, and you say 0. So you add one thing. We want to specify the bounds for all